Good afternoon, everyone. I'm going to give you guys just a brief overview on Ciguatera fish poisoning, or known as CFP for short. So CFP is the most common non-microbial foodborne illness in the world, and it is prevalent around the tropical and subtropical regions of the Indo-Pacific Oceans, Mediterranean and Caribbean. It's particularly prolific around the West and South Pacific region and affects many Pacific Island communities that rely on the reef system for sustenance and trade. The causative compounds are called ciguatoxins and are produced by this benthic microalgae here called Gambidiscus. The toxins are bioaccumulated into the marine food web from the herbivorous reef fish that graze on the macroalgae to the omnivorous and carnivorous reef fish that then predate upon them. People then go and catch these fish, and if the fish are contaminated, can cause severe illness in an array of different symptoms. Currently, though, there's actually no reliable test methods that can be used in the remote locations around the Pacific, and therefore Pacific Island communities actually just avoid collecting fish from certain locations or commonly implicated species. But what we're seeing is with global warming, there's an expansion of these tropical and subtropical latitudes, and therefore the habitable range of Gambidiscus is actually expanding. This has become evident as Spanish mackerel along the New South Wales coastline of Australia have caused intoxications. Latitudinally, this is actually the equivalent of Northland New Zealand, so it could potentially become a threat to our inshore fishery. So my PhD is going to focus on four main research objectives. The first is around compound discovery, and that's having a look at two recently characterized species and seeing if I can find the new toxins that are being produced by them. The next is going to be around using a liquid chromatography tandem mass spectrometry method. So it's going to be improving the extraction of fish and microalgae, as well as expanding the suite of secondary metabolites monitored. The third is going to be looking for a biomarker compound, and in particular one called 44-methylgamberone. And the reason being is that if we can identify a biomarker compound, we can potentially predict or preempt Gambidiscus blooms, and so then therefore hopefully reduce the amount of intoxications that occur. As part of this, I'll be looking at the production of this compound by cohabitating species, as there has been some evidence that multiple species produce it. And then finally, the fourth main section is looking at the bioaccumulation. And so do these recently characterized compounds bioaccumulate in the marine food web, and could they contribute to CFP intoxications? So most importantly, overall, I'm hoping to be able to contribute to the field of CFP in the way of identifying these new compounds, finding a way to be able to analyse them, and then hopefully determining whether or not they're going to play a role in CFP. Thank you very much.